Hi there. So as part of the MSX testing of the cassette drive, I'm going to look at trying to repair the cassette module. When I was loading off the server, that all worked fine. So I want to see empirically what the issues are with this tape drive. So I've got a USB oscilloscope here, and that actually has a 2-volt peak-to-peak calibration output. Let me try and show you. So that thing there comes out as a I think it's a 1 kilohertz peak-to-peak signal, which we can use to try and do some calibration. So first thing is we're going to hook up the input. So we're talking about the mic input there to the tape deck, and then we're going to grab these clips. So we're going to have, so it's 1 kilohertz, 2-volt peak to peak, so that's good enough. Whoops, one crocodile clip there. We'll just push the insulation up a bit so it doesn't short out. And then the ground. Okay, and then we're going to put it on here, and we're going to tape this for a bit. So we should, I'm just going to turn the volume down a bit, because we should, when we are recording this, we should be able to hear it. Is that on mic? Hang on, let me just double check I'm on the right socket. Yeah, that's mic. So yeah, so that tone is the tone from here. So we'll record a few seconds of this, and then what we're going to do, we're going to go over to the workstation, and we're going to have a look at the output from the oscilloscope, and we should be able to compare the waveform generated from tape playback with the reference signal. So we've got 2 probes here. We'll rig up these probes. It'd be a mess of wires, but it should work. Rig up these probes so we can see those 2 waveforms side by side on the oscilloscope trace, and hopefully that should give us a nice reference, then a benchmark where we can start tuning it up and potentially repairing this device. There's not much in the way of controls. There's azimuth control to adjust the head pitch and things like that. I don't know if the problem is if there is a distortion that we can detect. That distortion may be maybe a problem with the amplifier. Who knows what it is. It might be a mechanical problem, in which case that's a bit of an issue, but we'll see. It might just need a clean up. Anyway, so that's quite a few seconds of recording. So we stop that, pull that out. I'm going to adjust the volume so it's not too loud. Let's rewind and see a preview of what that was. Play that. So that should be a clear tone. That's not, I don't think, that doesn't sound like a square wave to me. So that's not a good sign. But it's good from the perspective that we've got a consistent reference signal, we've recorded it, the playback is not great. So it's either the recording of it or the playback of it is dodgy. So we're gonna plug it into the ear. Take these wires off. So these wires, let's get the colours right so we know which is which. So the blue is going to be the reference. So that's the ground. We can ditch that one. And ground's going to be there. Okay. Oh, it's not even remotely connected. That's better. So that's going to be the ground. That's going to be the reference. This one is going to be the output from the cassette tape. So that's going to be yellow. And we've got to put the ground on there. Okay. And we'll hook that up there. So that's good. So now let's go over to the bench and see what we can see. So here we are back on the bench, and the green is the reference signal, the yellow is what's been recorded. So as you can see, I mean, none of these things are going to be in sync. That's fine. I wouldn't expect it to. They are independent. There's no syncing at all, no frame syncing. But you can see the frequency is about the same, but the issue is that waveform at the bottom, the yellow waveform, should look the same as the green, and I think you can agree it doesn't. So there's that sort of peak at the top. That's not so bad, but it's the spacing of the pulses that gives you the data stream, and the frequency is okay. But at the bottom, you can see here that's not great. That is a nasty little trace. So yeah, at least we have a window into what is going on with the tape deck. It's obviously having a problem. We've got to start fiddling around with it, I suppose. What's nice is that as we're adjusting, we can hopefully try and make those two waveforms match. So yeah, interesting. It's a useful window into fixing these tape decks, and hopefully we'll get to a point where we can make it match and make the MSX load. 2400 board is not too bad for tape, should be able to handle that. Any more than that, there are some machines which record faster than that. You're really starting to hit the limits of what's possible with an ordinary tape deck. If you've got like a commercial, like a DAC or a DAT tape, then that's fine. But for domestic recorder, 2400 board is about the same. In fact, a lot of 8-bits have an even slower data rate. I know my old Oric, you can have slow or fast. Fast is 2400, it's the same. Slow is 1200, and it takes hours to load anything. But it's a bit more reliable. So you've got that change, that possibility. With the MSX 2400 board, certainly the version I have, you're fixed. So we've got to make it work in that window of bandwidth. So yeah, let's get fiddling.